Hello viewers, in today's session we are going to discuss another important and conceptual problem from definite integrals, and in this session we are going to discuss this integral involving the fractional part function. So we have to evaluate this integral in which the lower limit is minus 7 by 4 and the upper limit is 6 and the integrand is a fractional part of 4x, right? So here let us first call this integral as I, right? So to evaluate this integral, we have to make use of some important concepts from functions, right? And moreover we'll also utilize the concept of periodicity of fractional part function, right? So let us see how easily we can solve this integral using the concept of functions and the concept of periodic functions. Now let us first quickly see the definition of fractional part function, and we know that if we have a function, say y is equal to f of x, that is equal to fractional part of x, then fractional part of x is defined as the difference of x and greatest integer of x, right? So this is the definition of fractional part function, and we know that the period of fractional part function is equal to 1, so we can write the period t as equal to 1, right? Okay, now see here we have this function that is the fractional part of 4x, right? So if we take this function as the g of x, that is fractional part of 4x, then the period of g of x is given by say t1, then t1 is given by t by 4, because here we have the coefficient 4, right? And we know that if we have the function say f of x and its period is t, then the period of f of say ax is given by t by a, right? And here we write modulus of a. So if the period of f of x is t, then the period of f of ax is given by t divided by the absolute value of a, and here a is not equal to 0. Now see, for example, we know that the period of sine x is given by 2 pi, then the period of say sine 4x is given by 2 pi divided by a mod of 4. So here we have the coefficient, that is 4. So the period of sine 4x is given by 2 pi over 4, that is pi over 2, right? So this concept is utilized here. The period of fractional part of x is 1, and the period of fractional part of 4x is given by 1 divided by the absolute value of 4, and that is simply a t over 4, and t is 1, so we have the period of g of x as 1 over 4. So in general we can say that the period of fractional part of ax is given by t divided by a mod of a, and t is 1, so we have 1 over mod of a, and a is not equal to 0. So now let us write this integral I as integral from minus 7 over 4, and here we have 6, and fractional part of 4x can be written as g of x, right? Now let us rewrite the limits in the form, that is minus 7 over 4 can be written as minus 7 times 1 over 4, because 1 over 4 is the period of g of x, and here we have 6, so let us write 6 as 24 times 1 over 4. So we have now expressed the limits in this form. Minus 7 by 4 can be written as minus 7 times 1 over 4, and 6 can be written as 24 times 1 over 4, so that here we have the period of this function g of x, right? So now here we will utilize the an important property of definite integrals involving the periodicity of functions. Now see, we know this property, that is, if we have here p times t, and here we have q times t, and here we have a function, say g of x, right? And p and q are some integers, and t is the period of this function g of x. So this integral can be written as q minus p, that is difference of these two integers, times the integral, that is 0 to t, and here we have g of x dx. So now if we compare this integral with this one, then here the value of p is 7 minus 7, right? And the value of q is 24, and t is 1 by 4. So p is minus 7, q is 24, and t is 1 over 4, right? So here this integral, that is I, is now equal to q minus p, that is 24 minus minus 7, and here we have 0 to t is the period of g of x, and for t we can write 1 by 4, and for g of x we can write a fractional part of 4x, and here we have dx. Now this is 24 plus 7, because minus and minus becomes plus, and this is 31. So here we have 31 times 0 to 1 by 4, and fractional part of 4x can be expressed using the definition of fractional part of 4x. So here for x we can write 4x. So fractional part of 4x is now equal to 4x minus greatest integer of 4x, right? So now we have to evaluate this integral, and let us first concentrate on this term. Now see, here the limits of integration vary from 0 to 1 by 4, and x lies between 0 and 1 by 4, right? So x lies between 0 and 1 by 4, and if we multiply this inequality throughout by 4, then here we have 0 times 4 is 0, and here we have 4x, and here 4 and 4 get cancelled, so we are left with 1, right? So this inequality suggests that 4x, it lies between 0 and 1. So what we have done here, the limits of integration vary from 0 to 1 by 4. So x lies between 0 and 1 by 4. So if we multiply this inequality throughout by 4, then we get this inequality, and this inequality claims that 4x lies between 0 and 1. So by the definition of greatest integer function, anything lying between 0 and 1, the greatest integer of that term should be equal to 0. So here this term is equal to 0. So now we are left with 31, and here we have 0 to 1 by 4, and here we have 4x minus 0, because greatest integer of 4x is 0. So we have simply 4x, and here we have dx. Now we can take 4 outside the integral, so we have 31 times 4, and we have 0 to 1 by 4 x dx, and this is 31 times 4. The integral x dx is x square over 2, and the limits are from 0 to 1 by 4. So the value of this integral I can now be written as 31 times 4, and we can now substitute the limits and we can take the difference. So when we take x is equal to 1 by 4, here we have 1 over 16 because this is x square, and here the denominator is 2, and when we take 0, this term is 0, so here we have 0, right? So now we can solve it. 31 times 4, then we have 1 over 16 times 2, so this is 4 times 4 16. So here we have 4 times 2 8. So the value of this integral I is equal to 31 over 8, right? So viewers, this is how we can find out the value of this integral using the concept of fractional part function and the periodicity of fractional part function.